Hey, what's up guys? This is Zach from Wire Customs, and today I'm going to show you how to install your 12 volt conversion kit from Vintage Auto Garage. So the first thing we're going to do is disconnect the battery and remove it. This makes the rest of the process that much safer. We're not going to have a battery in the car, in the truck, or whatever you're working on until we're completely done with the whole process. So let's get this out of here. So here what we have is our two different starter solenoids, the old one that's still in the car, and here's the new one. I don't like people just to blindly follow instructions. I want people to be able to grasp what they're actually doing and what the difference is. So on this one, this is a ground wire going to a little button on the dash, the push start button. That's how these early Fords worked. So what this does is just grounding the starter solenoid. It switches over and allows power to go from the battery cable, which is this right here, to the other side of the starter relay, to the starter wire. This goes down to the starter. Now, since that's ground switched, this works a little bit differently because since we're not going from positive ground anymore, we're going from negative ground. This is going to ground our relay, and it's going to kick it over for this little jumper wire and allow this thing to actually kick on and start the starter. Say that 10 times fast. So this is how we're going to get from this 6 volt positive ground to 12 volt negative ground. So here's the visual difference, and what we're going to go ahead and do is just connect the battery cable. This cable that's also on the side of the battery cable, that's going to be for the fuse box of the vehicle. Very, very common for the fuse box to take it from the starter solenoid side. This is the starter side. So when we go to take all this apart, take a mental note of how it was set up, because we're going to replace this wire and we're going to replace this wire in the process. Now we're going to replace the battery wire and starter wire since we're right here. Now it's good to note that this is actually reversed when it comes from where the battery comes from on this new starter solenoid. This side now is the battery side. This side now is the starter side, so make sure you don't get that backwards. So we got the wire with the red in here showing that it's positive, and that's going to go on the side with the jumper. So now, since this side is going to be our battery side, we need to hook up the fuse box to that side of the starter solenoid so we can get power. Now if you have any accessory wires that's hanging off like what I have here, I'm not sure what this goes to. This is some aftermarket stuff. Let's leave this unplugged until we figure out what that is if you have that situation. This is why it's so crucial to have the battery out of the car and not hook it up yet until the very end, because we're going to be hooking up our fuse box here, but we haven't got to the step where we actually protect the gauges. We don't want to blow our gauges, so don't hook the battery up until we're completely finished. So now I'm going to go ahead and attach the starter wire to the starter solenoid. So when I crawl underneath the truck, I can disconnect the old wire and replace it with a new one without making 2 trips. This, you can actually see the core of the wire. This can get wet, it's going to start to corrode and actually mess up the voltage in the system. So this is the new one from Vintage Auto Garage. It actually has shrink wrap on both sides. You cannot see the core of the wire anywhere. This could get wet and the wire on the inside will actually never corrode and won't mess up your voltage. So I wanted to take a moment to show you something that I find really, really cool. We are doing a 12 volt conversion kit right here on this fire truck. It has an old flathead in it. Inside, outside of the truck, all looks original, very classy looking. And since we have a flathead in there anyways, we want it to look period correct. So what we're doing is taking the generator out. The generator will charge 12 volts, but if you start adding anything electrical onto the vehicle, it's not going to keep up. What we have here is a Power Master. This looks like a generator, but it's actually an alternator inside of a case to appear like a generator. Technically, it's a GM1 wire alternator. So back here, we only have one terminal, and you can see that here. Very easy to hook up. You do not need a voltage regulator. This is going to take a lot of the wiring out of the engine compartment and really clean it up and dress it up. Look classy, look clean. At first glance, people won't even notice that it's not original type equipment. It just looks like it's very cleaned up inside the engine compartment. I am obsessed with these. It does have the option to bolt in the fan. So if you have a later model like an 8BA, like what's in this truck, you can still slap this on your flathead and not have to worry about trying to figure something out for the fan. We can still run the original mechanical fan on this flathead. So definitely keep this in mind when you're upgrading your flathead. This is going to let us to put a lot more accessories on this vehicle and retain the classic looks. So let's rip out the old generator and put this beautiful thing in there. Now the generator is going to be different from vehicle to vehicle. What I can suggest to you first is to remove any wiring that's on the generator. And if you have a setup like his flathead, remove the fan. Then go ahead and remove the generator mount bolt that's bolted right into the top of the intake. You can leave it on the bracket. If you think it's too heavy, you can take it off the bracket, flip it open, and pull it all out together. So check this out. This is the PowerMaster alternator, and it is notched on the bottom. That notch has a little detent on the bracket. So this allows you to be able to slide the PowerMaster back and forth probably 2 inches at least. So this kind of helps you line up the belt on the front, something that was a little bit harder to do on the generator, so that's a nice option. And once I get the belt straight up and down, I'll tighten it down on the bracket. Then I can put my fan back on and adjust my fan belt next. Alright, so my year truck didn't come with a horn relay. It has nothing. It's a straight ground signal from the horn button right all the way to the horn. So it's really important that we put in a horn relay. Now if yours did come with a relay, it's a 6-volt relay. Make sure you upgrade yours to a 12-volt relay. This is something that gets overlooked a lot on these conversions. Luckily this is in the kit, so I didn't have to think about ordering it. It just all came together. So I'm going to throw that in. I'm actually going to install it where the voltage regulator used to be, because there's a bolt hole that's there that's unused that I'm going to use to mount that horn relay. I'm not just going to throw it in there. I'm actually going to explain to you what we're actually doing in the process. Alright, so this horn relay is a 3-terminal. We have 3 letters right here, H, B, and S. So Hotel, Bravo, Sierra, these are the letters that we have up here. How we hook this up is H, this goes to the horn. Then we have B, this is going to have its battery supply, constant power right here. You can make an ignition power, but whatever you do, make sure you put a fuse on it before it comes to this spade. Then we have S for signal. This is going to be the signal from the horn button or whatever you're using to honk your horn. So what I'm going to do, since this is an F1, we have the wire coming right out of the steering box. That's the horn. It's going to be grounding it every time you push the button. So that wire is going to come up to the signal, and it's going to ground, switching the relay to have H become hot, because it's not hot all the time. So once you honk the horn, that's going to be grounding this relay, S, and it's going to be sending power to H, the horn. So make sure the horn is always grounded, and it's going to be getting this battery signal from right here. Now installing the signal switch to the column is actually really easy. It has this little loop right here. All you have to do is feed it in. Then from the screw on the bottom of the switch, it's actually going to tighten the clamp up. Get the clamp nice and tight so the switch isn't going to move back and forth while you're trying to use the blinker. Then you can start hooking up the wiring. Alright, so here's a part that could be a little intimidating for some people when we start wiring stuff, but if you break it down line per line, it's actually very easy. You just need to know what needs to go where. So we need to feed the flasher with constant power. We're going to get the power from the battery to the X terminal that's on the back of this flasher right here. So now we're going to hook my power coming from the battery to this fuse right here to the X terminal on the flasher. Now on the back of the flasher there's a terminal labeled P. That's going to go to the blue wire for this switch. So I am going to hook a spade up to that blue wire and plug that in. Now I need to hook the black up to the L terminal. Then we'll be done with the flashers. Now with these LED flashers, they're going to need to be grounded. So now I just need to find a good ground spot for my ground wire coming off the top of the flasher. Then the flasher will be completely done. Okay, so we're only down to a couple things left on this conversion. The next step is going to be the multi-gauge reducer. I have a whole video about this, so go back and check that out if you want to know more about this. But this is really awesome. It makes this conversion so much easier. So I'm going to show you how to do this portion of the conversion right here on my bench, opposed to trying to film up underneath the dash, just so you get a better view of what's going on. So you could run into a couple different gauge type setups. The main thing you need to know is all the gauges need 6 volts going into them. Right here I have one example. So what we have here is one power wire in. This one power wire is connected by these bars right here that's sending the power to the rest of the gauges. So you might only just have to run one wire in. Another example you might run into where these bars are not here and each gauge has its own 6 volts coming in. It can be ran either way. What I suggest is trying to stick to your original type of setup. If each one has its own individual wire coming in, give each one its own individual wire coming in. So what's great about this voltage reducer is it has multiple terminals right here for 6 volts. So we have one wire in that's going to be your 12 volts. One wire from this is going to be the ground. Then we have 3 6-volt outputs coming off of this. So we have one for each gauge if you have a wire going to each gauge. So I recommend hooking it up the way that it was originally hooked up in the car. Now it's really that simple. The other things to be said about this part of the installation, bolt this somewhere where it can get hot and not melt anything. So how this thing works is it creates heat, and that metered heat makes resistance, and that resistance steps the voltage down. So this is supposed to get really, really hot. It's doing its job when it's hot. As an example, where would I put it on here? I could probably put it down here in the unused area at the bottom and just bolt it through. You would never see the bolts from the bottom of the dash, and there's nothing here to touch it and get in its way. So you can use that as an example, or you can just find a nice easy area to put this. Now I want to take a minute to explain ammeters. This is something that usually confuses a lot of people. So the ammeter here, this is my ammeter on this dash, and as you can see, this is all original wiring. All I did was cut it out and pull it out of the car, so whatever was originally connected is still connected right here. This allows me to see that there was no ground wire on the ammeter. That's really important to note. Some of the vehicles, the power wire actually just curls around the outside of the ammeter. It's never even hooked up, and the ammeter reads the voltage through there. Some of them, that little circle is internal. So power is going in, it's circling around the ammeter, then coming back out the same terminal. It kind of reads similar to a coil. That coiled up portion, more or less, is pulling the ammeter from one way to the other. That's the best way I can explain it without going down a giant rabbit hole, but don't let that overwhelm you. A lot of ammeters just need a power in. Double check your wiring and your setup before you rip it out and start replacing it. Now another thing I want you to be aware of is the way that these gauges work. Power comes into each gauge. Each gauge has its own grounding wire going out to its own sensor. Those sensors create resistance in the wire, either by temperature or by pressure, and that resistance makes a voltage drop, and pretty much what all these are is just voltage gauges calibrated to watch whatever sensor it's watching, and that's going to show a voltage drop on the gauge technically. Then whatever's painted on the gauge is relaying you information. So don't get intimidated by gauges, they're very, very simple. So next we have the headlight relay. That's going to take the massive amount of power and switch it for you right here. It's going to make your high and low beam pedal on the floor much safer. It's going to make your headlight switch on the dash much safer. We don't want to run high current through that. We're not going to be adding a bunch of extra stuff. We're going to be wiring into the system that's already there. So your headlight switch is going to have a wire that comes off the headlight switch and into the high and low beam on the floor or wherever that high and low beam is located inside your vehicle. What we're going to do is break that connection, and we're going to switch that through this relay. So from that headlight switch, it's going to go into the yellow wire. That's going to go in here through the relay, then come out the red wire. The red wire is going to go to your high and low beam switch, and we're going to wire that in from the source, the power source, which is usually the middle tongue on the top. So I'm going to throw a picture in here so it'll help explain it for you. So the white here is actually going to go to ground, so make sure you strip that off and put it on a good known ground. Always test all your grounds before making connections. It's very simple to do with a cheap voltmeter. Switch over to ohms, put one in on the frame or a nice clean spot, put it on where you're going to put the ground, and make sure there's a connection between the two. Always double check all your grounds. Black is going to go to a constant power source. So what we're doing is really just controlling that high-low switch right here in the relay and not on the floor or on your switch in the dash. That's going to allow you to keep those two switches without upgrading those to 12 volts, but much safer with our 12 volt conversion kit. Now after we install these, all we have left is double check our battery voltage, make sure we have good voltage. I'll throw up some good voltage here on the screen. If you're not within this little range, you must charge your battery, you must replace it. An uncharged battery can actually damage the alternator, it can actually damage your starter. So double check your battery voltage. It might actually even throw in a couple complications that may look like bad wiring when it's really not. So I can't stress enough how important it is to have good battery voltage before startup. Okay, so now that we've finished the installation, it's time to take a step back and not get ahead of ourselves. Go through each thing that you changed on the vehicle, Make sure your connections look good. Pull on all your crimps. Make sure the crimps aren't loose. Make sure your battery has good voltage. Make sure there's no wires laying on something that's going to get hot, possibly melt. Once you checked everything, all we have left now is to connect the battery. Keep a close eye on the vehicle. Turn the ignition on. Don't start it just yet. Double check all your lights. Turn your lights on and off. Try out your blinkers. Have someone check your brake lights for you. Keep a close eye on your gauges, what they look like. Now, of course, your little multi-gauge voltage reducer is either going to show green lights or a green to red light, or a straight red light letting you know if something's working or not working. So keep an eye on that. Once you did all your double checking, make sure everything looks good, start the vehicle up. The starter should crank over faster. That's really normal. And I'd have to say that these early starters actually don't mind the 12 volts. They'll take them, they'll run faster, they'll run great. Start the vehicle up, check your charging voltage. This is really important. We don't want to run the vehicle for a long period of time with a low voltage. That could be telling you, hey, the battery's not good enough. We could be hurting the alternator. So we got to protect our investment. So now that I've done the complete conversion kit, I would have to rate the conversion kit. I would give it a 10 out of 10. I really liked it. I think it's a great conversion kit. Literally had everything that I needed for my whole truck. Ease of installment, I would probably give it a 8.5 out of 10. Really, all you need is just a basic level information. If you like this video, give it a thumbs up. If you have any questions, just shoot them down in the comment section. I'll answer every single question that you have about this kit or about purchasing your kit, what you might need, what you might not need. All of that depends on your vehicle and your style or your taste. And I look forward to hearing about your projects. I'm Zach with Wired Customs. Thank you for watching.